Hi everyone, this is Cheska and now we are going to talk about convolutional coder diagram. So this is performance number 6 in ECE 23. Now, without further ado, let's start. So, first, we are going to determine the convolutional coder rate of 1/3 in transition table, state machine diagram, and trellis diagram. So, here is our diagram that we are going to determine using the three of the following in the list below. So, next, first of all, what is convolutional coder diagram? So, the coder input and output are continuous streams of light. The coder outputs and outputs digits for every k digits input, and the code is described as a rate k over n code. If the input digits are included and modified in the coder output, and the code is described as systematic. So each input information bit corresponds to branching either upward for input information bit 0 or downward for input information bit 1 at a tree node. So, has been one of the most widely used error corrections in the digital wireless communications. It is a type of error correct code that generates parity by symbols, and it was introduced by Peter Elias in 1955. So next is, we are now going to determine the convolutional coder diagram within the output is N1, N2, and N3, wherein N1 is equals to input XOR M0 XOR M1. In N2 is equals to M0 XOR M1. And in N3, it's input XOR M1. Okay? Now, in transition diagram or transition table, in this transition, wherein if the input is 0, then the next state is 0, 0, and the current state is 0, 0, then the output is also 0, 0. And in the input is 1, and the current state is 0, 0, the next state is 1, 0, then the output is 1, 0, 1. Now, if the input is 0, and the next state is 0, 0, and the current state is 0, 1, then the output is 1, 1, 1. Okay, there, as you can see. And next, if the input is 1, and the current state is 0, 1, then the next state is 1, 0, so therefore, the output is 0, 1, 0. Next, in 1, if the input is 0 and the current state is 1, 0, and the next state is 0, 1, then the output is 1, 1, 0. Next, if the input is 1, the current state is 1, 0, the next state is 1, 0, then the output is 0, 1, 1. Next, if the input is 0 and the current state is 1, 1, the next state is 0, 1, then the output is 0, 0, 1. And next, if the input is 1 and the current state is 1, 1, then the next state is 1, 1, then the output is 1, 0, 0. Okay. That is the transition table. So, in the state machine diagram, here, you can see we have 4 states, the 0, 0, 0, 1, 1, 0, and 1, 1. Okay. Then, if the input is 0 and the current state is 0, 0 here, then the next state is also 0, 0, then the output is 0, 0, 0. And next, if the input is 1 and the current state is 0, 0 here, then the next state is 0, 0 also, then the output is 1, 0, 1. No, I mean 1, 0, 1 here. Then next, if the input is 0 here, and the current state is 0, 1 here, then the next state is 0, 0, then the output is 1, 1, 1 here. The next, if the input is 1, here, and the current state is 0, 1, 0, 1 here also, okay, here. Then the next state is 1, 0 here, then the output is 1, 0, 0, 1, 0. Next, if the input is 0 here, 0, and the current state is 1, 0 here, then the next state is 0, 1 here, then 0, 1, 1, 0, then the output is 1, 1, 0. Okay, and next, if the input is 1 here, and the current state is 1, 0 here, and the next state is 1, 1, then the output is 0, 1, 1. Okay, next, if the current state is 0 here, and the input is 0 and the current state is 11 or 1, 1 is here, and the next state is 0, 1, then the output is 0, 0, 1. So the last one is here. If the input is 1, then the current state is 1, 1 here, and also the next state is 1, 1, then the output is 1, 0, 0. Okay, so that is the state machine diagram. And next, here, in the trellis diagram, then if the input is 0 and the next current state is also 0, 0, and the next state is 0, 0 here, then the output is also 0, 0, 0. Now next, here, if the input is 1 and the current state is 0, 0, and the next state will be 1, 0, then the output is 1, 0, 1 here in the white line. Now we're going to this mint green color line. If the input is 0 here and the current state is 0, 1 and the next state is 0, 0, then the output is 1, 1, 1, right? Then in the sky blue color here, if the input is 1 and the current state is 0, 1 and the next state is 1, 0, then the output is 0, 1, 0. In the purple color here, if the input is 0 and the current state is 1, 0 and the next state is 0, 1, then the output is 1, 1, 0. Next, in the red line here, I hope you can see it well. Let me adjust my video. Here. Okay. So, in the red one, if the input is 1 and the current state is 1, 0 and the next state is 1, 1, then the output is 0, 1, 1. Now, in this indigo color here, if the input is 0 and the current state is 1, 1 and the next state is 0, 1, the output will be 0, 0, 1. And lastly, in the color green line here, if the input is 1 and the current state is 1, 1 and the next state will be 1, 1 also, then the output is 1, 1, 0. Okay. So, next is the summary. My summary is that In a state transition diagram, transition between the states are shown by paths connecting the states. A state machine diagram, sometimes known as a state machine diagram, is a type of behavioral diagram in the Unified Modeling Language or UML that shows transition between various objects. And the trellis diagram, by exploiting the repetitive structure, provides a more manageable encoder description. The nodes of the trellis characterize the encoder states. That's all. Thank you. This is Cheska Loretizo once again. This is MO6, performance number 6 about convolutional coder diagram. And again, this is Cheska Loretizo from BS Electronics Engineering 3A. That's all. Thank you.